Math 2, Assignment 1.2. Adding two binomials. These are binomials because there's two terms. To add these, we simply need to add the like terms together. So we would have 3x, so we could stack them up. We could bring this one over here, 2x plus 1, and write it like that. So then 3x plus 2x is 5x, 2 plus 1 is 3. To multiply two binomials, see, now there's a multiply in between instead of an addition in between. To multiply, what we're going to do is we're going to distribute each of the terms in the first set of parentheses through the second set. So 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. So now I've distributed the first term through the second set of parentheses. Now I'm going to distribute the second term through the second set of parentheses. So 2 times 2x is 4x. 2 times negative 1 is negative 2. Now we notice that these two are like terms, so we get 6x squared. Negative 3x and positive 4x adds up to 1x, and then minus 2, and there's our answer. Okay, so a second example. We want to add these together so we can line them up with their like terms, kind of stack them up together like this. 4x plus 5x is 9x. 3 plus 2 is 5. And there's your answer. For multiplying, there's a multiply in here. We're going to distribute the first term, 4x, through the second set of parentheses. So 4x times 5x is 20x squared. 4x times 2 is 8x. Then we're going to distribute the positive 3 through the second set of parentheses. 3 times 5x is 15x. 3 times 2 is 6. So we have 20x squared. These two are like terms, so we can add them together. Plus 23x, and then plus 6. So there's your answer. Now these processes are related to geometry. They're related to the perimeter and area of a rectangle. To get perimeter, we add all of the sides together. So this is adding the sides. So if this side is 2x plus 5, then this side would also be 2x plus 5 inches. And if this is x minus 3, then this would be x minus 3 inches. So to get the perimeter, I'm going to do 2x plus 5 plus 2x plus 5 for the top and bottom, plus x minus 3 plus x minus 3 for the two sides. So 2x's and 2x's is 4x's, and one more is 5, and one more is 6. So we have 6x's. 5 plus 5 is 10, minus 3 is 7, minus 3 is 4. So 6x plus 4 is the perimeter. Now area of a rectangle is base times height, so that would be your 2x plus 5 multiplied by x minus 3. 2x times x is 2x squared. 2x times negative 3 is negative 6x. 5 times x is 5x. 5 times negative 3, negative 15. These are like terms, so we can add them together. 2x squared minus x minus 15. So the area is 2x squared minus x minus 15 inches squared, because we did inches times inches, which makes it inches squared. And area is squares. It's a number of squares that fit inside something, so it's square units. That would be what area would be. It's the number of squares of a given size that will fit inside something, so that's why we use square units. prime factorization. Remember making factor trees. So two numbers that multiply to get 28, 2 and 14, two numbers that multiply to get 14, 2 and 7. And you keep going until all these numbers are prime. Remember the prime numbers are 2, 3, 5, 7, 11, 13. These are numbers that can only be divided by 1 in themselves. So the prime factorization of 28 then would be 2 squared times 7, because 2 times 2 is 2 squared and then times 7. Okay, 11. Well, 11 is in my list of prime numbers, so it's its own prime factorization. That won't do anything else. And then 57. 3 will go into 57. Let's see, 3, 27, 19 times. Both 3 and 19 are prime numbers, so the prime factorization is 3 times 19. Greatest common factor. To get your greatest common factor of two things, the first thing you need to do is prime factor the numbers. So I'm going to rewrite this. This is 8 times 3, and 8 is 2 times 2 times 2. So that's 2 cubed times 3 times x squared times y. Okay, then 9 is 3 squared times x times y. And then 6 is 2 times 3, and then we have times y cubed. Okay, so now we're ready to choose our greatest common factor for these three values. The way you get them is you first off identify everything that's listed. So we have 2's, we have 3's, we have x's, and we have y's. So you list each item that's listed. Then you look through here and you pick out the biggest exponent on each one of them. So the biggest exponent on a 2 is 2 cubed. So we put it down here. We look through our 3's. The biggest exponent on any one of our 3's is squared. We look through our x's. The biggest exponent on an x is x squared. And we look through our y's. The biggest exponent is 3. So there's our greatest common factor. So the only thing we have left to do is multiply the numbers back out. So 2 to the third is 8, 3 squared is 9, 8 times 9 is 72, x squared y cubed is our greatest common factor. Okay, so for the second set of numbers, we have 5 squared times x squared, and then we have 2 times 3 times x squared, and then we have 3 times 5 times y. So we look through all of this and we list everything that's listed. So we have a 5, we have a 2, we have a 3, we have an x, and we have a y. Now we look back up here and we pick the biggest exponent on each one. So we look at our 5's. The biggest exponent is squared, so we make this squared. Oops, you can't see that, sorry. Okay, so we had our 5, our 2, our 3, our x, and our y. So the biggest exponent on a 5 is squared. We look through our 3's. The biggest exponent on a 3 is just 1. We look through our 2's. The biggest exponent on a 2 is just 1. So now the only thing left to do, oh, and then the variables. The x's, the biggest exponent on the x is x squared, and then on the y is a 1. So now we have 25 times 2 is 50, times 3 is 150, x squared y, and that's your greatest common factor.